This screencast is going to teach you about hydrates, so what a hydrate compound is, and then how to determine its formula given lab data. It's similar to an empirical formula problem that we learned about on Friday. So a hydrate is a crystallized ionic compound with water molecules incorporated into the crystal structure. So I know we haven't talked about crystal structures, but when an ionic compound forms, the atoms of the compounds in that ionic substance form what's called a lattice. So there's spaces in between those atoms. So if each of these circles is an atom in the structure, then those water molecules in a hydrate get trapped inside the crystal structure. So it's not that the hydrate looks wet, it just looks like a solid powder or crystal, but that water gets incorporated into the structure, so it does change its mass and change its properties. And you can determine how many moles of water are incorporated per mole of ionic compound by doing a similar calculation to the empirical formula problems we did on Friday. This would be an example of how you would write the formula for a hydrate. So this particular hydrate is a hydrate of zinc carbonate. It's named zinc carbonate trihydrate, the tri referring to the 3 moles of water that are there for every mole of zinc carbonate. So when you see this phrase anhydrous salt, a salt is a generic term for an ionic compound. And anhydrous means without water. So the anhydrous salt is simply, I'll come back to that, it's just the ionic compound on its own. So in this case, the anhydrous salt would be just the zinc carbonate. Then the hydrated form, or the hydrate, is the compound with the water incorporated. So then in this example, then it would be the zinc carbonate with the 3 moles of water attached. So you can determine the formula of a hydrate by doing a very similar calculation to the empirical formula problems we did on Friday. The difference is that instead of breaking the compound up into the individual elements, you break it up into its ionic or anhydrous portion and the water. So the first 3 problems, or the first few problems on page 20 in your packet, instead of giving you an actual compound, we just give them generic letters. So I'm going to do 2 examples from your packet. The first one is on page 20, and it's number 3. So we're calling this hydrate D. And then the question mark just means that you're trying to figure out how much water, how many moles of water is attached to this. So I'm going to separate this then into the anhydrous salt compound D and then the water portion. So we give you the mass of the anhydrous salt that you have, and because you don't know the formula for this ionic compound, we have to give you the molecular weight of it so that you can figure out the moles. Okay, so just like before, you're going to take the mass of the anhydrous salt and figure out how many moles of that you have, and then you're going to take the mass of water and figure out how many moles of that you have. So you're also given the mass of water in the problem. Just like with the empirical formula problems, I don't want you to round to sig figs. You're going to keep 4 or 5 decimal places on your answer, your mole answer if possible. So once you have both mole amounts, then you're going to divide both of them by the smaller of the two. So this is 1. And you're going to round your answer just like we did before to whole numbers. So you're figuring out the ratio of the ionic compound to water. So then the problem is asking you for the formula. So you want to make sure that you write that as your final answer. So here my ionic compound is just called D, and then for every 1 mole of D, there are 3 moles of water incorporated. So you show that by writing a dot and then the 3 moles of water next to it. You're also going to see on that page, actually on page 21, hold on, I need to redo it. On page 21, you're going to see that sometimes we give you lab data. So this is going to be very similar to the type of data you're going to record on the lab that we do on Thursday. So when you're looking at a problem like this and you're given lab data, a few things you need to know. A crucible is just a container. Okay, so this first number is just the empty container that we're giving you, the mass of the empty container. The second number, we're giving you the mass of the container plus the hydrate, so the substance with the water. And this third number is the container plus the ionic compound without the water. Okay, so the anhydrous salt. So you have to use that data to figure out the beginning mass of just the anhydrous salt and then the beginning mass of the water. Your ionic compound here is ammonium oxalate. So you're going to need to know what that formula is in order to figure out the molar mass so you can get the moles. Okay, so for the ammonium oxalate, if you take the mass of the crucible plus the anhydrous salt, because remember I want just the mass of the substance without the water for this piece, and you subtract from it the mass of the empty container, then that's going to give you the mass of the anhydrous salt that you're going to start with. So this is 1.054 grams. The molar mass of ammonium oxalate is 124. So that gives you 0.0085 moles. And then you're going to do the same thing for the water. Okay. Now if you think about this, up here in the data table, here you know the mass of the crucible and the ionic compound with the water. Here you have the mass of the crucible and the ionic compound without the water. So the mass of the crucible is redundant. So if I take the mass of the crucible plus the hydrate and subtract from it the mass of the crucible and the anhydrous salt, then that will give you the mass of just the water by itself. Okay. So then you're going to do the same thing. You're going to take that mass of water. You're going to determine the moles. And then you're going to take those mole amounts and divide both of them by the smaller. But in this case, you're going to end up with a 1-to-1 ratio. So then the formula for your hydrate is going to be 1 mole of the ammonium oxalate for every 1 mole of water. And you don't have to write the 1 in, but you can if you want. So that's how you do hydrate problems.